All right, perfect. So now that the recording has begun, I'm going to introduce myself again. I'm Ifra. I'm a product manager here at Wikimedia Germany, and my team is called the Wikibase Product Platform Team, and it's the team that built the newest addition to the data access methods, which is the REST API, the Wikibase REST API. And I'm going to take probably the next 15, maximum 20 minutes to give everyone a bit of an overview. It's mostly geared towards beginners and it's not very tech heavy, just so you have an idea of what the REST API was about and how and why we built it. And if you have questions, please wait until the end of the presentation. I also have some of my very wonderful colleagues here with me today, and if you do have technical questions, they will be more than happy to answer those as well. All right, then let's start with a bit of a background. Why did we want to do this? We obviously want more people to build applications on top of the amazing amount of data that Wikidata has to offer. But it's not really the easiest thing to do. Accessing the data for tools and gadgets and applications via the API is a little hard because the Action API, which is the API that we have originally, is a bit difficult to understand for beginners and use. It's not really the industry standard, and like documentation is there, but it's not as accessible. So why the REST API then? It follows the REST best practices. It has a published open API definition. It's easier to use and to scale, and it's more tailored to the Wikibase data model. So what does that mean exactly? So one thing, as you can see in the screenshot that's there, is that the REST API uses statements instead of claims. So on the right is an example from the REST API, and on the left is an older example from the Action API. What else? So there's a few other smaller changes that makes it a bit simpler to use. There's a new top-level property field that's introduced, which holds both the ID and the data type. There's a new value field that's added that consists of two fields, which is content and type. A few things were removed. For example, the main snack field was removed. And we also still add all the fields, even when there's nothing that was there in the response. So also when they're empty, all the fields are always included. Another thing that's there is that the REST API uses a flatter structure, as you can see again in the comparison between the two. And there's a few changes in the metadata as well. There's the revision ID and the last modified date that are included in the response headers. And success is represented as a 200 or starting with a 2 versus in the 400s, which is an error response code. And a few things have also been omitted, such as the title field and the page IDs. Okay, so as some of you might have known, that when we released the REST API first, we called it version 0, just because we were iteratively building on top of it and hadn't considered it stable. But as of November of last year, we have officially the first version live. And so what is the functionality that it has? So generally saying it can read and edit items and properties. So in total, it has 61 endpoints, and I've linked the Swagger documentation or the Open API specifications that we have there, and you can go through them, but it covers the general things like get, delete, put, and so on. There's also a lot of comprehensive documentation on the same page, and we also have a talk page on Wikidata itself that puts all the documentation that we've collected and written in one place, so you can easily access everything that you might need to begin using that. And you'll see that in action in the video that Jakob very kindly made after this. We've also put a lot of effort into writing really useful and structured error messages. There's authentication via OAuth. Something really cool is that we have patch endpoints that allows you to edit parts of items and properties, so you don't have to go through and edit an entire item when you just want to change something small. There's conditional requests that are based on revision IDs or last modified dates, like I just mentioned before, that these exist now in the headers. And here's some screenshots of what that looks like. So on the left is a screenshot of the OpenAPI specification, and on the right on the top is just a response that you'd get if you just get an item. So in summary, what does it do and what does it not do? So it can access full or partial data of individual items or properties, and then it can edit full or partial data of individual items or properties. So what can it not do? There's a few things that it can do for the moment. First is search, but there's a little bit that I can say about that in the next subtopic. It also is not meant to query Wikidata or traverse the graph. It also, right now, doesn't access data of entities in bulk, but this is also something that's on our list for discovery work because it's been asked here and there, and it's being used quite a bit in some of the applications that we've seen. And it also, right now, doesn't access other entity data, for example, lexemes or entity schemas. So it's been around for a little while. What is the impact that it has had? So the community, and not just the community, but beyond the community, have built some very cool applications, some of which are Wikidata and LangChain. And then again, when you get the slide deck, you can always click on the hyperlinks and actually go to these applications and try them out if you'd like. There's Paulina, and I think you'll also hear about them, I think, on Friday or maybe sometime next week. Also the software collab projects such as Wikidata one-click browser extension and Quick Statements 3.0. And I think that's also due to be released quite soon, or maybe is already there. And many, many more things that I haven't listed here. Another thing I obviously want to say is there has been an increase in usage over time and quite drastically. So a very small example that I've put here is the unique number of IPs calling the API was at approximately 121,000 in December of last year, as compared to 76,000 in October of that year and 54,000 in September of that year. And I'd shown these numbers also in the opening session there, and we'll keep track of them as well. And if you're interested in other data, please feel free to reach out to me after. So that's what we've done so far. What plans do we have for the future? So like we were talking about in the opening session, that we have been running the surveys since last October. We've been also doing a bunch of interviews. And something that comes up time and again is our developers asking for search to be built into the REST API. And we've started doing that since the beginning of this year. We also had, and I've linked the Fabricator board so that you can keep track of the work that we're doing and what the plans are. And we also made sure that there was like a proof of concept that we had created before towards the end of last year to gather some feedback. And we hope to continue this way of building going forward. Something that we're also obviously going to do the whole time is to regularly maintain and gather feedback on the API, like the version 1 that we have so far. Another thing that is definitely on the list for us to do is a comprehensive analysis and to keep gathering feedback on Action API. There's a session on Friday specifically for this. So if you're using the Action API, or if you've tried to use it, or if you want to use it and want to complain about it or want to sing its praises, please make sure to drop by to that session as well. And the last thing that's obviously on the list is that we want to do a proper discovery on additional endpoints that might need to be built into the version 1. An example obviously could be labels of linked entities and just bulk get, like I had mentioned before. Okay, while I wrap up, I wanted to also bring again the point about how to give us feedback. We're really open to feedback and we'd actually love to chat. So you can always make a ticket directly on the REST API Fabricator board that's also linked here. And ideally, you can tag the Wikibase product platform team. You don't have to. If you just make a ticket there, I'll make sure to see it and get back to you as soon as possible. You can also, if you don't want to go to Fabricator, you can also just leave a message or a question on the talk page for the REST API that's there. Ideally, you can just tag me and I'll get back to you there as well. Another way of reaching out or bringing us into discussion is sending a message on Telegram and tagging me. And in general, if you would like to have a bigger discussion or want to chat more regularly or iteratively, you can just email me. That's my official email address, just about the REST API and your use cases and how you'd like it to be broadened or changed in order to be better. That's basically the general intro to the REST API. I mostly wanted to be here and answer some questions. This was a shorter session than we had planned. But yeah, we have a lot of time for questions now because the next session will start only at past, so another 18 minutes or so. But I'm here and some of the developers are here as well. So now's the time. And I'm going to give like, I don't know, 10 seconds or so for everyone to absorb all the things that I've been talking about. I see that there's a question. Congratulations on the recipe, it's amazing. I think the congratulations go to Jakob and Ollie are here, so that goes to them. Do you plan to implement item merges? It's in the backlog. I would say like everything that's there in the backlog, I would have to go through the importance level of and to also see how relevant it is for other people and generally, for the use cases that are there. And then we'll see how we can do that. So I don't know if that's a good enough answer, but I know it's definitely on the backlog. Not the answer that you were expecting, but that's the best thing that I can promise at the moment. But I'm glad you like it. And I'm happy to hear that you're using it. Anything else? There's a question from Mahir. Are the differences in item representation from the Action API reflected in the item JSON that Wikidata itself stores? Don't know if any of my team is able to answer that. I'm not sure what you mean with this exactly. There we go.
Yeah, I can. Oh, okay. There you go. Yeah, ready. No is the short answer. Exactly the same inside the wiki page and the database, and the dumps are also the same. No, it's fine, Jakob.
There's another question. Does the API have a rate limit? Yes. Before the team yells at me, I want to say yes, that's what it is. And I think you can find the information ideally on the document on the page that's there that I've linked, the main REST API page. Is there a way to get the original data format in a REST API request then? You mean the way with the main snack and things like that, Mahir? I would say no, because, and the team can jump in, but I would say no. I think that was one of the reasons why we're doing that, just to have a more simpler way of presenting the data. There's a question from Lydia, or like Lydia's asking, among all the things that I mentioned still to be done, if there's anything that really stands out to anyone who's already here. I think bulk get was something, labels of linked entities was another thing that we were asking about. We're obviously working on search at the moment. So if there's anything along those lines that really stands out, that would be cool to know. There's a question from Jorge. I see the item search is already in the OpenAPI Swagger documentation. Does it implement search keywords like has a Wikibase statement and different types of values for those statements, like dates? So we're starting off, well, like I said, we only started at the beginning of this year. And right now we're starting off with very simple search and prefix search. And the goal would be towards the end of this year, towards the latter half of this year, to get into faceted search or to get into keywords like has Wikibase statement and things like that. So if you're interested in testing and giving us feedback, please reach out to me and we can, chat about it, or make sure that you can test the POC for the other thing when it comes out. But yeah, that's the answer to that question. Amazing. For us at Quick Statements 2.0, there are two things: A, item merging; B, getting labels of multiple items at once. That's good to know. I'm going to make sure that that's also added in our list. So like I said, merging was something that we hear of a little less, but getting labels of multiple items at once definitely asked for quite often, and we'll see how we can prioritize that work for sure. More questions or complaints or comments? While people are still thinking, I'm going to plug the next session, which is a very cool video that Jakob kindly recorded, which is going to show you how to build a very simple app from scratch in the REST API. So everything from where do I even start looking at the documentation to showing the app all the way in the end. It's going to be there for like an hour or so. And the amazing thing is, at least two of the developers are here. So even when you're having questions during the recording, you can definitely just ask questions here and we'll make sure that we can answer them. And if there's nothing else, I'm going to say that we can call this done. Oh, the patch endpoints are awesome to use. I hope Jakob and all you're here reading all your wonderful comments. Nice. Cool. All right. I would then say we can call this session done. I think we have, what, 10 more minutes anyway before the next one. So let's take a bit of a break and we'll be back here with the video playing in 10 minutes. Thank you for listening and asking good questions, and we'll see you around in a bit. Welcome back. We are going to start very shortly with a second session. And like I said before, and for the benefit of anyone that might have just joined just for this session, it's a video that was pre-recorded, but there are people from the REST API team who are here and will be happy to answer any questions towards the end of the session or in the middle if they'd like. And again, the sessions are live streamed on YouTube and they're also recorded. So please make sure that your mics are turned off and so are your videos if you don't want to be in the recording. I'm going to give my colleagues maybe 30 seconds or so to set up, and then they can start the video. And it's basically just an entire user journey on how to build a very simple application using the REST API. So everything from navigating to the documentation, to setting up yourself to select the right endpoint, and then just integrated that into a little app. Yeah, so that's going to be the session. Like I said, we're here. Please feel free to just write your questions in the chat. For anyone who might be watching this on YouTube and want to ask questions, you'd have to go sign up at the Data Reuse Days event link at the event page to get the link. And then it'll be super easy for you to just ask questions in the Jitsi room. Yeah, so I'm going to say maybe we can start the video or set it up already if we're good to go.
All right, hello everyone. Welcome to this live coding session while I'll build an application using the Wikibase REST API. My name is Jakob. I'm a software engineer at Wikimedia Deutschland, and I was part of the team that developed the REST API. And today I'll walk you through the whole journey from having an idea for a web application, then looking at the data on Wikidata, discovering the REST API documentation, and then finally building the app. The plan is to build a specialized editing interface for Pokemon types. Don't worry at all if you don't know anything about Pokemon. All you need to be aware of is that these are little fictional creatures that have 1 or 2 types. And what we're going to build is an app to change these types and display the label of the Pokemon item. And what we're doing is to first explore the data on Wikidata, then we'll take a look at the REST API documentation and where to find it. And finally, we'll build the app, which I've split into these 4 steps here, starting from displaying the Pokemon item's label, then fetching the statement data to get the type information, then editing the statements to change the types or to add new types, and finally using the OAuth mechanism to ensure that our edits are authenticated. So let's take a look at the data of our Pokemon and how they're modeled on Wikidata. Here's the Wikidata front page, and I'm just going to search for a Pokemon item. I'll choose Charizard as the first example. And as said, the goal for our application is to display the label of the item we want to edit. In this case, it's Charizard. I'm going to stick to English labels. And second, we want to display and edit the type statements. Here we can see that Charizard is an instance of a fire type Pokemon. On Wikidata, types are modeled as instance of statements. And it's also instance of flying type Pokemon. So it has 2 types, and both of these statements have qualifiers indicating the primary and secondary type. So the first statement here that shows that it's a fire type Pokemon also has a qualifier with the applies to part property and the value first type indicating that it's the primary type, and then the statements saying that it's a flying type Pokemon has a qualifier applies to part second type indicating that it's the secondary type. There are also examples of Pokemon that only have 1 type. Pikachu is an example of that one, where we can see that it only has 1 instance of statement referring to a type. And of course, Pikachu is an electric type Pokemon. Okay, with our data sorted, we can take the next step and take a look at the Wikibase REST API documentation. I'm going to jump back to the front page of wikidata.org, and knowing that I'm a developer who wants to create an application using the REST API, I can just scroll down to the Get Involved section and click on the link that says Retrieve and Use Data from Wikidata. Now we're on the data access documentation page with lots of useful information when you're a new developer. In our case, I already know that we're going to use the REST API, so I'm going to jump straight to that section and click through to the main page of the Wikibase REST API. And from here, we have links to the most useful bits of documentation when we're creating an editing interface that uses the REST API documentation. On one hand, it's the authentication documentation page and also the OpenAPI Swagger documentation that tells us how to create specific requests to the Wikibase REST API. Let's take a quick look at the authentication page first. So on this documentation page, we can see how to set up an OAuth client and how to then use these credentials in our application. I'm not going to spend too much time on this because I have already set it up for our demo application today, but it is all very well documented here, and you can just read it later when you write your own application. Let's take a look at the OpenAPI Swagger documentation. That's this colorful page here, and this is detailed information on how to retrieve and edit different parts of Wikidata items and properties. So if we scroll down here very quickly, we can see that here's our REST API endpoint to create items, here's an endpoint to retrieve a whole item, then same sections for site links, properties, retrieving labels of items and properties, retrieving descriptions, and so on and so forth. Okay, let's jump right into creating our application. So this is the application that we'll be working with. Here today you can see that it runs on my local machine on port 7777, and so far it's pretty much a blank page, so we're almost starting from scratch. It has a text saying hello world, it has a headline, and it has a login button. As I've already told you, I've set up the OAuth authentication beforehand. I've created my OAuth client on my local development wiki. So if I click here, you'll see that it redirects me to my local wiki, and if I click allow, it redirects me back to my app and I'm authenticated as the admin user. I'm using my local wiki here instead of Wikidata, just so that I can safely play around with my app and make edits without worrying that I'm changing production data on Wikidata. Using beta Wikidata would also be okay, but since I have my local wiki set up here, it's just more convenient. I don't need to worry about creating OAuth consumers on beta. Let's take a look at the code that powers this so far. We have, as you can see, a couple of view files here, and then we have an app.js file that powers it all. I'm using Express.js as the server, which is a little Node.js web framework, and it's fairly simple so far. We're loading Express, we're creating an Express app, we're using port 7777, we're using EJS as the templating engine. I'm hiding all the OAuth setup behind this function for now, which you can take a look at later, but I didn't want to go through all these steps in this demo since it's mainly about the Wikibase REST API itself and not about the OAuth authentication mechanism. And then we have our index route here, where it renders the index EJS template, which we can see here. It has a header and it has the hello world text, and if I change it and refresh here, we can see that it updates itself accordingly. So that's what we'll be working with here today. So what we want our app to ultimately do here is display a little input form for our Pokemon items on this front page, and then when I select a Pokemon, I want to get to the page where we can view and edit its statements, its type statements. And as said, I've been using my local development wiki here to authenticate, and I'll also be using that to fetch data from. I'll quickly show you what I've prepared here so far. So on my local wiki, I've also prepared a Charizard item, which is modeled just like it is on Wikidata, just with a little less data. So we have our English label here, and we have the two type statements. And for our first step, we'll just create the form here as said, and we will use that to get to our new Pokemon page that we still have to create. So let's jump right in. I'll create the old school form here, and I'll just say form action Pokemon. And in here, we just need an input field with a little text. Enter a Pokemon item ID. And we want a text input field with a name and a placeholder Q123. And when I reload, we can see that we have our input field. So I'll pick the item for Charizard, which was Q5. And of course, in a real application, I would want a proper type ahead item search input field here, but to keep things easy, I'll just use an input field for IDs. And now, of course, this page doesn't yet exist. That's because we haven't created it yet, and that's what we'll be doing next. Back to our app.js we go, and I'll create a new route definition here and call that, oops, what did I do here? And call that /Pokemon. And just like the one above, that takes a request and a response. And in here, for now, I'm just going to render the Pokemon template in a similar way to how we're rendering the index template above. Call that Pokemon. And I'll pass down the ID that we get from the query parameter at the top here. And for that, I'll do a const ID equals rec query ID. Whoops, not ideal, ID. And then we can pass that down here. I also need the templates. I'm going to copy this one, call it Pokemon EJS, and I'll delete all that stuff, and I'll just add a title instead containing our ID for now. Let's see what that did. Great, there's our Pokemon page. Not looking like much so far. It shows us the ID that we enter, so if I enter Q4, then we get that ID instead. The next step is to actually use the REST API for the first time and get ourselves the label. For that, I'll go back to the Swagger documentation page that we've seen before. And as said, here we'll find detailed information on all kinds of endpoints that the REST API has. And I'll just show you how I would use this, I'll keep scrolling and reading these endpoints basically until I find one that looks like it does what we want. Here's a section called labels. That sounds very promising. And specifically, we're interested in retrieving a single English label. I'll stick to English labels here. Here's the endpoint to get all the labels, but as we can see, there's one here that says retrieve an items label in a specific language, which is exactly what we want to get. It takes two path parameters, an item ID and a language code. So here we would pass in the QID of our Pokemon, and for the language code we would always use English in this little demo app. So I'll copy this link here and then I'll go ahead and create a get label function that returns our label. So in here I essentially want a function called getLabel, and that should take an item ID, and here I'll just create a function called makeAPIRequest. That doesn't exist yet, but it will in a second. And here I'll paste the path that I just copied, and in here we'll have to pass the item ID, and as said, the language code will always be English. So now we have to create this makeAPIRequest function, and that's going to be an async function makeAPIRequest, and that for now takes the path that we just passed there. And we need, in addition to the path, obviously the REST API base URL. I'm just going to copy, that's also documented in the REST API docs, but in my case we need my local wikis base URL, so I'll just do const REST API base URL equals, whoops, there we go, and we want /rest.php/wikibase. So now we need to actually make the request. I'll use the built-in node fetch function for that, so we'll do return fetch, and then REST API base URL plus the path should be exactly what we want. But in addition to just making the request, we also want to conform to the MediaWiki, to the Wikimedia user agent policy. So I'll immediately stop sending the default user agent and provide my app's custom user agent. For that, we'll have to send the corresponding header. So we'll just do headers user agent. And then in here I'll do data reuse days version 0.1. And here you would put an email address, and I'll pick that out of my my environment variables, process and email. And finally, we already know by looking at our request here that we get a JSON response back. We get a JSON string containing the actual label, which is convenient. So I'll just wrap this in parentheses. Not all that. I want this. And I'll do await fetch .json, calling the JSON method, and that will make it so that our makeAPIRequest method immediately returns the response body as a JSON object. So let's see if that worked. So if I did that correctly, I should be able to do label await get label here with our ID. and I need to make that an async function. And if I go back here and refresh, we see nothing because I didn't pass it down to the template yet. And if I do label here and then put the ID in parentheses and refresh, then we see Charizard, which is Q5. I believe I also have a Pikachu in my local wiki, and there we go, Q4 is Pikachu. So now we've made our first API request, we've sent the user agent header, and we've seen how we can find the API endpoints that we need for the job. In our case, we wanted to find the one to get labels. And that concludes the first step of building our little web application, displaying a Pokemon label, and on to the next step to fetch statement data. Let's take a look at our documentation again. We want to get statements in this case. So here we are in the label section. I'll scroll down to the statement section, and right at the top we see that there is an endpoint to retrieve statements from an item. And that's exactly what we want to do. We can see that it takes the item ID as a path parameter, and then it even takes an optional property ID to filter statements by. And it responds with the statements in a map, mapping property IDs to lists of statements. So in our case, looking at our item, we want to request the instance of statements, and then in our code we want to get these two type statements from the list of instance of statements, because there might be others. So let's take a look at how we can do this. I want to first fetch the instance of statements, and then I want to find the primary type statement from within those instance of statements, and then I want to do the same for the secondary type statement, and only for the first one we actually need to make an API request. So let's create a function to get statements. Function get statements, probably an async function, and also spell that correctly, and it takes an item ID and it takes a property ID. And the property ID is instance of in our case. I'll copy the path here again, and I'll do const response equals await make API request, and that takes our path. And for the item ID, we want our item ID, and then we said we also want to filter by property ID, and that is our property ID. And because it returns a map, but I think in our case we actually only want the list of instance of statements, I'll return the response with the field that is our property ID, and if that doesn't exist, I'll return an empty list, and that way we only get this part here. So let's see if that actually worked. Get rid of this, const instance of statements, get statements, wait, get statements, and then we want the ID. And because the IDs are different on my local wiki, I stored them in an ids.json file to make that not too confusing and have differing hard-coded IDs flying around. I'll just require that, and then we can refer to them by label. And then here I'll just do ids.instance of, and that might work. Let's see. Instance of statements. I'll need to refresh this page, and then we can look at our terminal, and here are all our statements. All our instance of statements, right? It's not all of them, but only the ones we're actually interested in. So now I need to make a function to filter or to find the primary type and the secondary type statements from within those instance of statements. And I'll do that just by defining a function called find statement with qualifier, because what we ultimately want to do is find the statement with the applies to part first type qualifier for the primary type statement, and then accordingly for the secondary type. So function find statement with qualifier, that takes a list of statements, it takes a qualifier value, so a qualifier property first, and then a qualifier value. And here we want to return, and we want to find the statement, and that should look at each statement separately, and our predicate is to find some qualifier, so statement.qualifiers.sum, where the qualifier is exactly the one we're looking for, and that's the one that has qualifier.property.id equal to our qualifier property, and qualifier.value.content should be equal to our qualifier value. Let's see if that worked. So I'll do const primary type statement equals find statement qualifier. We'll pass our instance of statements in here. Then we want applies to part as the qualifier property, and we want the primary type item as the qualifier value. Let's see if that worked. Console log primary type statement, refresh, and it worked. So now we do the same thing for the secondary type statement, and then we can pass them both down to our template. Secondary type statement. Now I can go here and say, whoops, primary type is primary type statement dot value dot content, and secondary type is secondary type statement dot value dot content. And that didn't work because I didn't change the qualifier value, so it's finding the same statement twice. And now it's correct. You may have noticed that I've cut a few edge cases and corners here, for example, not handling the case where some Pokemon don't have secondary type, or not handling cases like these not even being Pokemon and so on. But I'll just keep cutting these corners for simplicity, because I mainly want to show off the REST API here. Great, so now we have our two statements that we want to take a look at. So let's make this pretty now. I want to turn these two QIDs into select fields showing the currently selected type, and I also want to list all the available types in there. Or ideally we would want to fetch all the available Pokemon types dynamically, but I think for simplicity's sake it's also okay if we know that there's a limited number of these types to store them within the application, and that's what I did in this case. I'm keeping them in our ids.json file, and I'll just pass them down from there. So I'll do all types is IDs all types, and that contains the list of available types here. And now I'll do this rather quickly because it's not that interesting for what we're doing here. I'll have a field wrapper, then I want a label for our select, and that's the label for the primary type, and that should say primary type. And then here we want a wrapper for our select field, and the select field itself for the primary type, no ID. And in here we want an option for no primary type, I'll call that none. And now I want to iterate over the list of available types in all types. And whoops, close this loop. And here I want to do option value is the actual type, and the label should be shown here, so I'll do all types type. That's where I hard-coded the labels in there for now. And I also want to select the current value, obviously, and I'll do that by showing or adding the selected attribute here if the type matches the current value of the type statement. So we do a primary type statement and primary type statement dot value dot content is equal to type, and then we add the selected attribute, otherwise we don't. Let's see if that worked, and it did. Primary type fire. So now we do all that for secondary type. Just replace the word primary with the word secondary here as well. Secondary, and that's it. And that concludes the second part of building our app, fetching the statement data. Let's do some editing. So first I'm going to add a button and a form again to our view here. So I'll do form, action, update types, and that should be a post form, and then I'll move all of this in there. And I also want a submit button at the bottom of our form. So I'll do input dot button dot is primary is light. That's a submit button, and it should have a value saying update types. See what that looks like. Oops. There it is. And it looks like this, and when I click it, nothing happens because we haven't defined the route yet. So back to our app.js we go, and this time we'll define a post route. So we'll do app.post and call it update types, and again it takes an async function with a request and a response. And here I want to just redirect us back to the page that we came from if the edit succeeded. So I'll do res redirect, and then I want us to be redirected back to the Pokemon route with the ID that we came from. And in order to get the ID that we came from, I need to first pass it from the form, but I already know that I'm going to call this this field ID. So I'll do const ID equals rec.body.id. Because it's a post request, the ID will be part of the body. And then here we can just do ID. and that should be it. Let's see. So I'll add a good old hidden field in here. So input type equals hidden. Name is ID as said, and the value is our ID. Let's see if that works already. So if I go back and then click here, now I get back to the page that I came from, which is what I wanted. So now let's take a look at what we need to do here. So we have three cases. We either want to add a new type statement, we want to change the type of a type statement, or we want to delete a statement. And we will add a statement if there was no original statement. So if there was no original statement and the new type value is not none, then we want to add a type statement. Then if there was an original statement and the new value is none, we quote this too, then we want to delete the type statement. And if there was an original statement and the new value is different from the old one, we want to change the type statement. And I'll ignore the fact that I need to do all this twice for now, but this is roughly the logic that will follow here. And it already reveals that we need to send some more information on from our form. We need the original. We need the statement IDs of both the primary and secondary type statements, and we need the original values. So I'll go back to my form and I'll send those as hidden fields as well. So I'll do input type hidden, name should be primary type statement ID, value should be primary type, I'll copy that. Of course with that, primary type statement dot ID, I think, yeah, there we go. And then the same for the original value, original primary type, and that should be the same dot value dot content. And now we want to do that as well for the secondary type. So I'll do my trick here again and just replace the word primary with the word secondary a couple of times, and here as well, secondary. Okay, and now we can take a look at making the actual edit here. So back to our app.js we go, and let's define ourselves some variables. I'll do const statement ID equals request body primary type statement ID. Is that what I called it? Primary type statement ID, yes. Then we do const new type, and that should be rec.body.primary type. Then we also need the original type, which was rec.body.original primary type. And now we can start typing this out in code. So if there was no original statement ID and the new type is not none, then we want to await and add type statement. And for that we need to pass on the ID and the ID and the new type. And we also want to create this primary type, so I'm only focusing on the primary type statements here, with the first type qualifier already. So I'll also do a const type qualifier value here, and that should be IDs.primary type. Type qualifier value. Right. So let's see how we can add a new type statement. Here's our documentation, and we want to add a new statement to an item, and we're exactly at the right spot already. Let's take a look at these docs here. It takes an item ID as a path parameter, and then the request body is a statement. And we of course want the property to be instance of. Then we want to pass a value with our type as the content. And then we also want to immediately give it the first type qualifier applies to part first type. So let's do that. I'll copy the path here again, and I'll define our new add type statement function. Function add type statement, and that takes the item ID, it takes the value, and it takes the type qualifier value. That returns make API request, and here's our path, and again we just replace the path parameter with our item ID. We now need to make a few small changes to our make API request function, because we wanted to not only make GET requests but also POST requests and other kinds of requests. So I'll add a parameter here for the HTTP method, and I'll make it default to GET. And I'll also allow callers to pass a JSON body. Then here I'll just pass down the HTTP method, and here I'll add the body, and we need to make sure that it exists, and if it does we can JSON stringify it, JSON body, and we also need to make sure that we're making requests with content type application JSON here. But that should be it for our make API request function. So all I need to do here now is specify that we want to make a POST request, and here I need to define our statement. So our statement has a property, and that property should have the ID instance of, and it also has a value, and the value has a type value, so it's not a no value or some value statement, it's an actual value statement, and the content is our value containing the type. As said, we also want to have the qualifier, so let's add that as well. And it only has one, so I'll do this. And the qualifier also has a property with an ID, that's ID applies to part. and has a value, which again also has type value, and content is the type qualifier value. Let's see if that already works. To do that, I'll quickly delete the primary type statement from our Charizard. Okay, sure. Delete. And let's try that out. Primary type none. Set it to fire. Update. And it looks like it worked. Let's see if it's back here. And it did. Great. So that's working. Next, we want to handle the delete case, which should actually be nice and quick. So let's go back here to our documentation and see how we can delete a statement. Statements are uniquely identified by their ID, so we can have a route here that doesn't take an item ID and only the statement ID. And I'm going to copy the path, and as said, it only takes the statement ID as a path parameter, and the entire body is actually optional in this case. Let's go back to our code, and we'll do an else if here, and if there is a statement ID and the new type is actually none, then we want to await delete type statement that takes the statement ID, and we'll just define this function. Function delete type statement takes the statement ID and will return make API request, which takes the path that I just copied. At least I'll need to pass down the statement ID, and all that's left here is to say that the method should be delete. That might already work. Let's see. And none, and click, and it worked. So all that's left now is the case for changing the type value. Let's take a look at the documentation for how we can do that. There is an endpoint that says it can be used to change elements of a single statement, and that's exactly what we should be using in this case. It takes the statement ID as a path parameter, and as the body it takes a JSON patch document, which consists of a list of patch operations. For example, a replace operation in our case is going to be used to replace the value of the statement. JSON patch is a nice format to describe changes to a JSON document, and it is relatively simple once you get the hang of it. So I'll do what I did before. I'll copy the path again, and I'll now cover the last case here where we want to say that else if there is an existing statement ID and the new type is different from the original type, then we want to await change type, which takes the statement ID and it also takes the new type. So let's define our function change type that takes statement ID and it takes the value, and here we can do return make API request with the path that I just copied, statement ID again, and the method is patch in this case, and the payload is a patch document containing a list of operations, in our case only one, with the operation type being replace, the path being the path to the field that we want to replace, in our case value content, and the value that we're getting from our method call, from our function call. Let's see if that does the trick. Charizard, primary type none, I'll change it to fire, then I'll change it to electric, and that's working. Great. So the benefit of using patch here is that everything else in the statement stays exactly as it is. So if it already had a primary type, applies to powered first type qualifier, then that is going to stay exactly as it was if all we're doing is replacing the content. Now I need to quickly do the same thing for our secondary types. And to do that, I'll do some sneaky editing here and turn our variables into two changes or updates, essentially. I'll paste this in here and then do some magic to turn this into an object real quick. Like that. And now I can duplicate this and replace primary with secondary again. And here as well, secondary. And now I'll just loop over these two updates for const statement ID, new type, original type, type qualifier value of updates, and then we copy all that in there. And I think that should actually do the trick. Let's see. Fire, that still works. Flying, set it to fire electric, why not? Great, that works. Delete, works. Add, works, just to prove that it actually does something. Fire, fire, fire none, and fire flying. Great, that's working. So now we can get to the final step of building our application, which is authentication. If we take a look at the edit history of our item, we'll see that all the edits so far have been made anonymously by temporary accounts, and that will stay like that no matter whether we're logged in here or not. And what we'll do next is pass an authorization header alongside our edit requests to make sure that these edits get attributed to the user that's logged in into our application. For that, we'll have to make some changes to our make API request function, and I'll have to pass down a user object here, and we're going to add an authorization header in here. Depending on whether we're using OAuth version 1 or 2, this is either a bearer token or a more complicated set of parameters and values. The particular library I'm using here is based on OAuth 1. So we'll have to pass down the user and also the request method of the current request and the URL. The URL is of course just the base URL plus the path. And I want to do that only if the user object is actually passed. So now what we're going to have to do is pass this user object down from our update types route handler to all the different make API request function calls. Const user equals rec session user OAuth, and now I'll pass the user down here and everywhere else. User, and then also here and there. here. And I believe that's it. Let's make sure we're actually logged in. Allow. Q5. Whatever. And let's look at the revision history now. And now we see that the edit was made by the admin user. And that's it. That concludes us building our little application here. We've seen a lot of code flying around in the last hour. I hope it was still interesting, and I hope I've inspired some people to now go and build more useful apps. I've linked all the code that we've just seen here. It's all in this repository. I'll also leave a link to the OAuth library that I've been using. There's an example in there that I've pretty much followed exactly as it was. There's also the REST API documentation page, and we always love to hear feedback about the REST API from people using it and trying it out. So yeah, thanks for listening and have fun with the rest of the data reuse days.
Okay, we still have 3 minutes after this very amazing video from Jakob. And as he mentioned already, if you just want to absorb all the information that you've gotten over the past hour or so and would just like to get in touch with us later on, please feel free to just write on the talk page of the REST API or email either Jakob or myself or anybody from the team. And we'd be super happy to just help out. I'm going to give people maybe, I don't know, 10 seconds or so. We have, like I said, 3 minutes. We can wait until then. But if I don't hear anything for the next 10 to 15 seconds, we can then call it a day. And obviously, huge shout out to Jakob for putting the work in and doing the recording and everything. There is a quick question that's asking, the idea of connecting to the local wiki instance makes sense. Is there a documentation to set that up? Is there general documentation about this? I'm sure it's maybe just not from the REST API side, just generally probably in the system. Is Ollie or Jakob, do you know better? Yeah, go ahead, Jakob.
Yeah, so if it's about setting up a local development wiki, then I can recommend a tool called MediaWiki CLI, exactly the one that Ollie also just linked in the chat. Thanks. And yeah, that's pretty much the tool to be used for local wiki development.
Okay, 1 more minute. Any very last quick questions to the team? If there isn't anything, I'm going to say a huge thank you to everyone for being here. And yeah, we're looking forward to seeing you here for the rest of the reuse days. Bye.